Hello, my dears. Today we're going to talk about a different type of quadrilateral. We're going to focus today on rhombuses and rectangles. So we're going to focus on those two very specific types of parallelograms. So let's take a look at their properties. So the first one is a rhombus. Rhombi is just the plural of it, so it's more than one. I just redrew the picture because there's not a lot of space in there, and I want to be able to mark up my picture. So a rhombus has 4 congruent sides. So that means all the side lengths are exactly the same. So in my rhombus, I'm going to put a tick mark on all 4 sides to show that they're all exactly the same. My diagonals are perpendicular. So diagonals, remember, are these pieces that are going essentially diagonal within my picture. And perpendicular means they are making 90-degree angles. So in the center here where all my diagonals meet, I'm making 90 degrees, 90 degrees, 90 degrees. So I've got 4 groupings of 90 degrees right in the center of my rhombus. And then my diagonals bisect the opposite angles. So bisect means cut in half. So if I'm looking at the angles that are across, the like for example, this angle here and this angle here would have to be exactly the same because they're cut in half. So I could say like this one's 40 degrees and this one's 40 degrees because they are bisected and they're the same. And because they are parallelograms, angles that are across from each other should be exactly the same. So since these two are both 40, these two should also both be 40 degrees. Okay, so we're going to use that information and we're going to talk a little bit about rhombi or rhombuses. And then the second type that we're going to talk about is rectangles, which is one you're probably very familiar with. Rectangles have 4 right angles, right? So all of these are 90 degrees, a right angle. And then my diagonals are congruent. So of these 4 pieces here that are across in the center, all 4 of these lengths are exactly the same. So I'm putting a tick mark on all 4 of those lengths. So we're going to use that information and we're going to talk a little bit about rectangles and rhombi. So for questions 1 through 4 here on my notes, all of the quadrilaterals are rectangles. So I'm going to use that information as I go through. So for number 1, it says ABCD is a rectangle. Find the length of AE. So AE is this length right here. Is what I'm trying to solve for. I know that in a rectangle, all 4 pieces of my diagonals are exactly the same. So this piece is the same, this piece, and this piece. Well, since they're all the same, I'm just going to take those 2 equations and set them equal because they are congruent. So my equation becomes 4x minus 3 equals 2x plus 7. And then it just becomes a really quick algebra problem. So I'm going to subtract 2x from both sides. I get 2x minus 3 equals 7. I add my 3 on both sides. I get 2x equals 10. And then I divided both sides by 2. I get x equals 5. Now I'm not finished with the problem because it wants me to find the length of AE, which is one specific length, but all of them are exactly the same. So I'm going to take that 5 and I'm going to plug it into the equation, and it does not matter which equation I plug it into. So I'm going to plug it in right here to this x. 2 times 5 is 10, plus 7 is 17. So the length right here of ED is 17. That means the length of AE is exactly the same. So the length of AE is also 17. So I did that by plugging in. Okay, so rectangles all have diagonals that are congruent. Number 2, if JKLM is a rectangle, find the length of KM. So again, I've got some diagonals here that bisect each other. I know all of these pieces are exactly the same. Because they're the same, I'm just going to take the 2 equations and set them equal to each other because they are congruent. So I've got 4x minus 15, excuse me, equals 9x minus 80, and then I'm just solving for x. So subtract 4x on both sides. I get negative 15 equals negative 5x minus 80. I add 80 to both sides. I get 65 equals negative 5x. Or sorry, this should be a positive 5, my fault. Oops, just realized that. And then divide both sides by 5. I get x equals 13. And then I'm trying to figure out what the lengths are. So I'm going to have to take this number and I'm going to have to plug it in. Now, again, it does not matter where I decide to plug it into. So I'm going to plug it in right here. 4 times 13 minus 15. So if I do that, I get 37. So each one of these individual pieces is 37. To find the length of KM, that is this whole length here. So I know that this one is 37. That means that NM is also 37. So to find the full length, I'm just going to take those and add them together. So to find KM, I'm doing 37 plus 37. So the length of KM is 74. Number 3. If it's a rectangle, find the measure of angle DEG. Now, I can do this one a number of different ways, but what I know is that in a rectangle, these are always equal to 90 degrees, right? Now, I see this angle right here, 2x minus 10, that's just this piece here. Okay, just this one. X plus 6 is just this piece right over here on the bottom of G. I know that these two are both on the interior of my equation, and since a rectangle is a parallelogram, I know my side lengths are parallel to one another. These angles right here are alternate interior angles. And I know, back from like chapter 4 or whatever one it was, that alternate interior angles are congruent. So because they are congruent, I can take these two equations and set them equal to each other, because congruent means they're exactly the same. So it's a little algebra. So I subtract x from both sides. I get x minus 10 equals 6. I add 10 to both sides. Excuse me, I get x equals 16, which is fantastic, but I'm not done. I'm trying to find the measure of angle DEG. So DEG is this piece right here in pink. It's the other part of the angle. So what I can do is I can take this 16 and I can plug it in, and it does not matter where I plug it in. I'm going to plug it in right here because this one's easier. So 16 plus 6 gives me 22 degrees. So I know this one right here is 22, which means this one over here is also 22 degrees. I know in total, this 22 and my pink angle should add up to be 90 degrees because it's a rectangle. So what I can do is I can say, okay, if I know that this whole thing is 90, if I subtract the 22 from the 90, I should get what's left over in the pink right here. And when you subtract those two, you get 68 degrees. So this angle right here, angle DEG, so that means you start at D, go towards E, and at G, just this angle in pink right here is 68 degrees. So reading the question is really important, which means this angle over here is also 68 degrees. Okay, rectangles. So corners of rectangles add up to be 90 degrees. Got some right angles there. Last rectangle problem. If this one's a rectangle, find the measure of angle SUT. SUT. Now, SUT is this angle right here. This is what I'm trying to figure out, right? That's what I'm trying to find. Now, what you're going to notice is this angle over here is 3x minus 22. I know that these are parallel, so I have alternate interior angles, but the alternate interior is this angle over here. So since this angle is 3x minus 22, that means this angle right here in purple is also 3x minus 22. I also know that this angle here, x minus 4, is alternate interior with this angle over here. So this one's also x minus 4. Now, I know if I combine the pink and the purple angles together, I should get 90 degrees because this is a rectangle. So I want to write an equation that says if I add the pink angle, which is x minus 4, plus my purple angle, which is 3x minus 22, I should get the full angle of the corner, which is 90 degrees. So then it becomes an algebra problem. So I'm going to start by combining my like terms. X and 3x is 4x. Negative 4 and negative 22 is negative 26. I want to get the x's by themselves, so I add 26 to both sides. I get 4x equals 116. And then I divide both sides by 4. I get x equals 29. Now I'm not done because I'm still trying to figure out what this pink angle is right here. So to figure out that pink angle, angle SUT, I'm going to plug in. Right, so I know this angle is x minus 4, so I just plug in my 29 into the x. So 29 minus 4. So angle SUT is 25 degrees. There you have it. Now I'm done with my rectangles. Next four are all about the rhombus. So I'm gonna come back to my little cheat sheet here. I remember that in a rhombus, my four sides are congruent. I also remember that my angles are bisected or cut in half. And I also know that in the interior, all of my angles should be 90 degrees each. They make some perpendicular angles there with my diagonals. So number 5 says, if this one is a rhombus, find the value of x. Now, both of these are on the exterior. Excuse me. I know that in a rhombus, the exterior, all the sides are congruent. They're exactly the same. So since they are congruent, I'm going to take these two equations and I'm going to set them equal to one another. So my equation is 8x plus 17 equals 13x plus 2. And then it just becomes quick old algebra, your fave. So I'm going to subtract 8x from both sides. Then I'm going to subtract 2 to get all my constants on the same side. I'm going to divide by 5. I get 3 equals x, and the problem, only asks me for the value of x, so I'm finished. If I wanted to, I could plug it in just to be sure that my answers were correct, but since I'm always right and I never make a mistake, I'm not going to check my work. I'm going to move on to the next one. All right, number 6. If ABCD is a rhombus and AC equals 82, find the value of x. So I know from A to C, this whole thing is 82. I also know that this small piece right here from A to the center is 6x minus 1. Now, I know that in a rhombus, the sides that make up the diagonal are congruent. So I know that A to the center and C to the center should be exactly the same thing. So since this one's 6x minus 1, this one's also 6x minus 1. I know if I combine the two together, I should get 82. So I want to write the equation, maybe I'll put like a little P here for myself. I want to write an equation that says from A to P, if I take that segment and add it together with this segment over here from P to C, I should get the whole thing AC, which is 82. So my equation becomes 6x minus 1 plus 6x minus 1 equals 82. And again, your fave, algebra. Combine like terms, 12x minus 2 equals 82. Add 2 to both sides. 12x equals 84. Divide both sides by 12. I get x equals 7. Again, I could plug it in just to be sure that they were the same, but there's my answer. Okay, last two. Number 7. If PQRS is a rhombus, find the value of x. Now, this time I notice that I am pointing to the interior of the rhombus, and I'm pointing to an angle, so there's a little degree symbol there. I know on the interior of a rhombus, each one of those angles is equal to 90 degrees because there's a perpendicular bisector there. So because this is, right here, this is 90 degrees, all of them are 90 degrees. So I'm going to write an equation that says this equation given to me, 8x plus 2, is equal to the angle on the interior, which is 90 degrees. So my equation becomes 8x plus 2 equals 90. And then quick algebra. Subtract 2 from each side. 8x equals 88. Divide both sides by 8. X equals 11, and the equation, or sorry, the question just asks me for the value of x, so I'm done. Last problem. If DEFG is a rhombus and the measure of angle EDG is 4x plus 6, find the value of x. Now, we're going to go through and mark up, excuse me, sorry. I'm going to mark up the picture with what I know. I know in a rhombus that the angles are bisected. I also know that angles that are across from each other are congruent. So because this piece of angle G is 51 degrees, that means this piece over here is also 51 degrees. Then that means, hey, this is 51 at angle E, and the other side of angle 1 is also 51 degrees. That's great. That's so much information given to me. I also know that in the interior, each of these is 90. Okay, so if I want to put a little 90 here, I can. The last thing I tell you is that angle EDG, so this whole angle D, the whole thing, is equal to 4x plus 6. Now, I've got a lot of different ways that I can go about this problem. The way that I'm going to go about it is I'm going to say to myself, okay, I know that this whole angle is 4x plus 6. That means that angle F over here, the whole thing here is also 4x plus 6. I know if I add together all of the angles inside this quadrilateral, because it's a quadrilateral, I should get 360, right? So what I could do is I could write an equation that says angle D plus angle E plus angle F plus angle G should equal 360 degrees. So that is one way that I can go about it, and I actually think that's what I'm going to do for this problem. I know a quadrilateral has 360 degrees, so I'm going to use that to my advantage. So angle D plus angle E plus angle F plus angle G equals 360. And like I said, it's really just essentially an algebra problem from here. So I'm going to substitute in angle D is 4x plus 6 plus, now angle E is both of the 51s together. So that's a total of 102. Angle F is again 4x plus 6. And then angle G is another 102. So you could do it this way. You could also just multiply, right, by 2. And that would really, so I don't have to add it up twice. But however you want to do it, it does not really matter. From here, I'm going to add some like terms together. So 102 and 102 is 204. Plus 6 and 6 is 12. So that's a total of 216. Plus my x's, 4 and 4, that's 8 x's, equals 360 degrees. And then subtract 216 from both sides. what's that? 8x equals 144. And then divide both sides by 8. I get x equals 18. And there we go. And I'm finished with the problem. So that was one way you could have done it. You also could have broken it down into like smaller triangles, right? So like could have said, hey, that's a triangle. This is worth 180 right here, and then figured out the unknown angle. Like there were a lot of different ways to go about it, but I knew that a quadrilateral was 360. So I just added all of the angles together and set it equal to 360. Okay, so now we're done with rectangle and rhombuses. So you may now flip it to the back and try your rectangle and rhombus homework / practice. Hopefully this was helpful for you. And that's all I have. Have a grand day. Now there's an awkward moment while I stop recording. Okay, bye.